Sophie from Skedulo, and welcome to this video on getting started with optimization extensions. By the end of the video, we will have covered a few key things. First, we will go over what optimization extensions are and what they can do for you. Next, we'll cover how optimization extensions work, and then we will work through building a basic optimization extension. Finally, I'll point you to some resources where you can learn more. Before we get started, you should have the following prerequisites. A good understanding of how Skedulo optimization works. I will link to documentation on it in the video description. A Skedulo development environment to build in, and the Skedulo CLI installed and configured. For more on that, see my video on it linked in the description. Now that we've got all that, let's talk about what an optimization extension is. Optimization extensions enable you to create custom scheduling logic to meet the specific needs of your organization and enhance your scheduling workflows. With these extensions, you can build, deploy, and apply your own rules more effectively through Skedulo's platform, reducing both time and effort. These are built using Skedulo connected functions. These extensions are integrated into Skedulo's optimization recipes, and once created and deployed, your scheduling teams can use them easily within the web app to optimize the scheduling process. So what does this mean in practice? Let's think about the following scenario. You're a healthcare provider and you always want to try and allocate the same resources to the same account to help improve continuity of care for your clients. You could use an optimization extension to achieve this, and that's the example we're going to build in this video. But first, let's take a look at some of the technical aspects of optimization extensions. There are two main things to understand when building one. The product data object. This contains information about the jobs that are due to be optimized. However, it does not contain anything that the optimization engine actually acts upon. It's read-only reference data. The feature model. This contains the data that the optimization engine actually uses. And for our use case, we're going to be generating and providing it with new resource dependencies. Don't worry if this isn't completely clear yet. We will be digging further into these as we build our extension. The first thing we're going to do is clone the optimization extension example from Skedulo's Github. I've put a link to it in the video description. This example is very basic. It will simply allocate every single job to the same resource, but it's a great starting point for what we're doing today. The code will look very similar to anyone who's ever developed a Skedulo connected function, as that's what they are, with the addition of some new helper libraries. The file we're interested in today is the routes file. This contains the logic of our optimization extension. However, for more complex solutions, we may wish to split this logic across multiple files. If we take a look at the transform schedule function, we can see that it simply maps every single allocation, which is a job to be allocated to a resource, to a single resource dependency. In our scenario, we want to go beyond this to group our jobs by account and then create a list of resource dependencies to represent these. This means that, at the end, we'll have one resource dependency per account, each with a number of allocations, representing the number of jobs passed to the optimization engine. Now we're going to make a few changes to the code to achieve our goal. The first thing we need to do is from the feature model, collect all of the allocations that are related to jobs, but not activities. We can do this by getting the metadata records from the feature model, and if they are jobs, combining their job ID and their model allocation ID. Once we've got this information, we'll then use it to build a simple map of job record to a list of model allocation IDs, bearing in mind that model allocation ID and job allocation ID are different things. Then, using the product data, we will turn this into a map keyed by account ID and containing a list of model allocation IDs. That means we now have all the information we need to create our new resource dependencies. Resource dependencies don't have any relation to account or even jobs, so we simply flatten them to a list of lists and we end up with one per account, containing however many allocations and by extension jobs there are for a given account. We can then pass this into the optimization engine in the same way it was done in the example code. Now you're probably wondering how we can test this locally. Well, luckily, Optimization Extension Framework provides a handy test endpoint. If we provided it with essentially the same data as we would to an optimization run, it will show us what will be passed along in that run with our optimization extension enabled. I've included a sample payload in the links in the video description. In our example, let's pass it 5 resources and 8 jobs across 4 accounts. We can run the function locally in the exact same way as any other with the Skedulo CLI by running sked function dev. Then we can use the optimization test endpoint with a tool like Insomnia or Postman. calling it with our optimization payload. Be sure to change the job and resource IDs to match ones that are in your tenant. And if we take a look at our console, we can see the output of each step. First, the combination of model allocation and job ID. Then that turned into a map. Then combined with account. And finally, flattened to resource dependencies. When we get the results back, we can look at the resource dependencies object and see that we get 4 arrays, each with 2 model allocation IDs, just as we'd expect from the source data. Now we've confirmed everything is working, let's set this up in the Skedulo web app and do a test optimization run. First, log in and go to Setup. Then select Optimization Recipes. You can use an existing recipe if you've got one, or clone one and configure it as you require. In our case, I've weighted it entirely to balance workload. Then make sure your optimization extension is selected and save the recipe. Next, go to the swim lane view and select the jobs you wish to test your optimization extension on. Click Optimize, select your recipe with your extension enabled, and run the optimization. Once it's done, you can take a look at the outcome. As you can see, our extension has ensured that all the jobs for the same account are allocated to the same person. This is just a simple example of using optimization extensions, but as you can see, this framework is incredibly powerful. Because there are connected functions, we can do all sorts of things, like using data from Skedulo or third-party APIs, query for additional record data, and much more. That's it for this video. Be sure to check out the resources and links in the video description, and stay tuned for future videos on optimization extensions, where we will cover both more advanced use cases, as well as a breakdown of the optimization engine, the feature model, and how it's all tied together.